All right, so we're going to be talking today about both segments and angles. So very foundational to the rest of this class. So points A, B, and C are collinear, which means on the same line. Oops. So before I even say the conclusion, I would say, well, B, C, and A on my line, right? Collinear. We have that AB plus BC equals AC, right? So it's the simple idea that a part plus a part is a whole. But we got to make sure that these conditions here, or the hypothesis, we got to make sure that's met. So we can't just go around saying that it's always true that AB plus BC equals AC, because it's not. Look at this picture, right? So if it's bent, it doesn't work, right? It's got to be a straight line. So this one's 59. Part plus part equals whole. Similar thing. We have that AC. It does say to assume that the hypothesis above is true. So we can say that AC is AB plus BC. And then it's just some algebra practice, right? So 12x minus 4, 2 plus x plus 9x minus 2. And we get, so I like to combine like terms like separately, like on each half first. So there's a lot going on here. We got 2 minus 2, which is 0. So we'll take a different color here and just get rid of that completely. And then we'll have a 10x, okay? And then I'll move this over, and get 2. And it really is as simple as that. So that's the answer. It's just x equals 2. What about this one? So this one, in class today, this one brought up a lot of good discussion, but I'm going to go through the steps. And all you got to do is just know the steps. And if you know the steps and the ideas behind the steps, you're going to be good. And you didn't miss much in class. So I know a lot of our listeners are at home now due to the quarantine. So 4 minus 2x plus x squared is 3. So normally in parentheses we do like foiling, right? But in this case, part plus part equals whole, we have a plus sign in the middle. So we're not really, the parentheses don't actually really mean anything. They're just kind of grouping them. We could erase them and it would mean the same thing. If that was a multiplication sign in between, not the same story, right? At this point, I like to reorganize everything so that I have, it would be plus 1, right? Why do we set it equal to 0? Let me show you why. Well, you remember how to factor from Algebra 1, and if you don't, you're on YouTube already. Just search on YouTube, how do I factor? There's some great videos out there. They're all waiting for you. So you would get that. Now, listen very closely. If a number times a number is 0, what could you say about these numbers? You know, you couldn't like figure out what exactly they are, but one fact that we know, and this is called the zero product rule. It says that if the product, remember this is the product, is 0, then one of the two things you multiplied is also 0. So the next step in here is to set each of these equal to 0. So then we get this kind of weird answer. So this doesn't happen very often, but when it does, we can kind of just summarize that. Well, I got 2x equals 1, so that's just x equals 1. So that's the answer. That's it. So that zero product rule step is really important in algebra, and we're hitting it again now in geometry. So this is the important thing. You need to learn how to write like this. So this little symbol means congruent. So it is read, line segment AB is congruent to line segment BC. So these two things here, they're objects. They're not numbers, they're objects. This here is a number. So going back up here for just a second, these are all numbers. Number, number, number. call them values. And in geometry, we call them lengths. Okay? So if you want to solve for AC and you know that the two line segments are equal, sometimes you put little dashes on here. Well, the answer there is just 8, right? 4 plus 4. All right? It's the notation that we're really working on right now. And this one was kind of just like a extra little puzzle, right? The first 4 prime numbers are these. So you could put those points on there. And this distance is 5. So that is AD. All right. To pause the video, read that diagram, read that table and get to know it. Pause the video and I'm going to move on. So you could call this angle KMJ or angle JMK. I had a student in class say that we could call it an acute angle. It's not right. Actually, it's not an acute angle. It looks like an acute angle, but there's no lock here. Like there's no like thing that says that this is a certain angle, right? Because to us in geometry, we have to be really skeptical. Like, because the picture could look like that, right? There's no like right angle symbol or anything locking it. So those are just things to look out for when we're doing this stuff, is how precise it is. Okay. What are 2 other names for that angle? Or the other one, we could also do LMK or KML. And then real quick to fill in this, I wanted to put points on here to help us. So I put 3 points on each of these, and I always did them in order. Should have probably done this before the video. The name of this, we would just call it angle AOB. And spoiler, all of them are just angle AOB. Some of them do have alternate names, special names, like this one. I like to sometimes use the right angle symbol because it's special, right? And this one has a special name that you already know. It's a line, right? Okay, so we have this Greek letter here, theta. So theta is going to be the letter that we use to denote the size of an angle, or the amount of turning. Theta is the amount of turning. So it's a number, kind of. It's kind of like, we'll call it 30 degrees, but degrees, they're not really a real thing, right? You wouldn't say, we turn 30 inches, right? So degrees are they're actually unitless in science, but we're not going to worry about that. So I'm just filling this in for you so you have it. But remember, this is all online, so you should have a chance to see that in the key. These are important here. Angles are congruent if they have the same measure. You can also look at the exterior of an angle. So that's like talking about, we don't ever really talk about this, but this is the interior angle. Interior space, maybe is a better word. And this is the exterior space. And there's an angle that goes through both of them, right? But they have the same geometric object. So later in math, like if you studied geometry in college, you would maybe distinguish between these better. But for now, we're just going to focus on that blue stuff, the shortest path. The smallest angle that you can use to describe an object is what we're going to do. And then another piece of notation down here. Okay. Take a moment to read that angle addition postulate. You'll kind of realize that, wait, we just did this. Yup. Same thing as the segment addition postulate. Part plus part equals whole. You just got to make sure your picture is drawn right. You got to have 2 angles that are touching. You don't want to have, you don't want B to be over here, or else then this isn't true. But as long as B is over here, where it should be, then we're all good. So this is 90. Part plus part equals whole. And then we could also set up that same equation, right? Whole is the part plus the part. So I like to put parentheses just to show that how we plugged it in. So I use that, means implies. So I use it to kind of just as an arrow to show like, hey, this is the next step. So you'll see me draw that sometimes. But it looks like the answer to this isn't very clean, right? But that's okay, doesn't matter. It's not that bad. So I think you'll need that answer when you start the homework. So give the homework a try, give it your best shot. Remember, the homework is not for a grade. You don't have to turn it in. It's for you to practice. I'm probably going to be making videos that go just over the homework, so stay tuned.